Good afternoon everyone. My name is Professor Swapnil S. Sudke of SND COE and Research Center Evla of Department of Electrical Engineering. Today we will discuss the topic of the subject Advanced Microcontroller and Embedded System. In this subject we discuss the topic that is stack pointer used in 8085 microprocessor. The first topic in this subject is that stack or stack pointer used in 8085 microprocessor. The use of stack pointer. The stack pointer is mainly used as a memory pointer which specifies to the memory location that read and write memory to that location. Then the typical uses of the stack pointer is to hold stacked bits that belong to the present function. Then it can be used for both the user as pass parameters and local variables, and CPU information, that is returning addresses at the time of subroutine call. Then we discuss some questions and answers about the stack pointer operation in a computer. First stack pointer is of 16-bit used in computer system. The PC and SP are utilized to store the memory locations, and as the previous location address is 16 bits, and so stack pointers are also of 16 bits, so that they hold a 16-bit data address. The second question is that what is the role of the stack pointer in the computer system? Following the principle of top to down, the stack pointer's role is to store the last program request address. So the arrival of new request pushes down the previous request. And the third question is that which stack is used in 8085 microprocessor? The stack in 8085 microprocessor follows the LIFO, that is last in first out stack, where the last stored data will be received initially. And the fourth question is that is stack pointer is a register? Yes, the stack pointer is a tiny register that stores the last program request address in the computer system. And the last question about this stack pointer is that what is the stack pointer in the ARM? The stack pointer register R13 used as a pointer to the active stack in ARM. Then the programmer view of 8085 microprocessor contains general purpose registers and special purpose registers. The general purpose registers are A, B, C, D, E, H, L, and the special purpose registers are SP, that is stack pointer, and PC, program counter. Then the stack pointer is a 16-bit register contains memory address. Suppose stack pointer SP contains FC78H, then the microprocessor 8085 interprets it. The memory locations have useful information from FC78H to FFFH, and from FC77H to 40H. The memory location doesn't have useful information in these memory locations. Then the basic operations of stack and stack pointer in the computer system. There are two operations of the stack. They are push operation and pop operation. Push operation. The push means pushing or inserting an element into the stack The push operation always increments the stack pointer and the pop operation always decrements the stack pointer. In the case of a push operation, we have to check whether there is a free space is available or not. If free space is available, we can go to the push operation. If free space is not available, then error message occurs, that is overflow. The overflow is to be checked in case of push operation respectively. Then if you want to push the element, that is and inserting the element into the stack, you have to push SA S, A, where S is nothing but a stack. If you want to insert a fourth element D using push in bracket S, D, but there is no space available to insert the element, then it indicates that the stack is overflow. The overflow terminology is used when the stack is full, and the algorithm of push operation is shown below. Then the algorithm of push operation. In this algorithm, we discuss this algorithm in a step-by-step manner. First, push in bracket stack in square bracket we put the value, then comma top, then comma max stack, then comma item, bracket complete. Then if in bracket top is double equal to maximum stack minus 1, bracket complete. Then in curl bracket, first we print overflow, bracket curl bracket complete. Then the condition else in curl bracket top is equal to top plus 1, that is first value is incremented by 1. Stack in bracket top is equal to item, curl bracket complete, and then end this algorithm of push operation. We perform any push operation algorithm by this manner in the stack pointer. Then pop operation. The pop means deleting the element at the top of the stack. In the case of pop operation, we have to check whether the stack is initially empty or not. If the stack is initially empty, then there occurs an underflow situation. Suppose the stack is empty, still you want to pop the elements in the stack, but there are no elements in the stack, then it leads to stack underflow. The underflow is to be checked in case of pop operation respectively. In pop operation, whatever the top element is present in the stack, that should be popped or deleted, so no need to mention which element will be popped. By default, the topmost element will be popped. The algorithm of pop operation is shown below. So this pop operation in the stack pointer is also having some algorithm we discuss step by step. First, pop in bracket stack in square bracket we put some value, comma top value in the stack, comma then item, bracket complete. Then first condition is if in bracket top double equal to minus 1, bracket complete. Then in curl bracket we print underflow in double inverted comma, then curl bracket complete. Then in else condition, in curl bracket item is equal to stack in bracket square bracket top, then top is equal to top minus 1, that is stack pointer value is decremented by 1, then curl bracket complete. In this manner we perform the pop operation in the stack pointer by this algorithm for any operation in the computer system. Then example of push operation of stack pointer in a computer. Example is is the elements are inserted in the order as A, B, C, D, E. It represents the stack of 5 elements. We want to push A element on the stack, then the top becomes 0, top is equal to 0. Similarly, the top is equal to 1 when B element is pushed, top is equal to 2. When the C element is pushed, top is equal to 3. When the D element is pushed and top is equal to 4. When the E element is pushed, then the top of the stack is equal to the 5. Similarly, we take any number of elements for the stack operation in the stack pointer in a computer system by pushing one by one element in a forward manner. So whatever the elements I have taken is placed in the stack. Now the stack is full. If you want to push another element, there is no place in the stack, so it indicates the overflow. Now the stack is full. If you want to pop the element E, element has to be deleted first. Then example of pop operation of stack pointer in a computer system. First, we have to use the pop operation to delete the elements in the stack. So just mention pop in bracket. Don't write arguments in the pop because by default it deletes the top element. The first E element is deleted, next D element, dash dash dash, and at the last A element will be deleted. When the top elements are deleting, then the top value decreases. When top is equal to -1, the stack indicates underflow. So this is the explanation of how the elements are inserted and deleted in the stack by using push and pop operation. Then applications of stack pointer in a computer system. The stack pointer having various applications in the computer system. These are the applications of the stack or stack pointer are string reversal, balance, parenthesis, then undo, dedo, then system stack for activation records, then infix, prefix, postfix, expression. Then at the last, why stack and stack pointer matters the most in the computer system operation. The use of stack pointer. The stack pointer is mainly used as a memory pointer which specifies to memory location that read and write memory to that location. The typical uses of the stack pointer is to hold stack bits that belong to the present function. The stack pointer holds the address to the top of the stack always. The stack allows functions to pass arguments stored on the stack to each other and to create scope variables. Scope in this context means that the variable is pop of the stack when the stack frame is gone and or when the function returns. The concept of stack came into limelight with the uses of terms bury and unbury, where those corresponds to calling and returning from the subroutine functions. To be clear in the concepts of stack and stack pointer, initially we need to understand the terms what is an array and linked list. An array is defined as the randomly accessible data structure where one can easily access the elements in this and in steady time. Binary search is a clear example of a random access data structure, while a linked list is defined as the sequentially accessible data structure where every element in this has to be accessed only in a specific order. A roll of tape is a clear example of a sequential access data structure. Thank you.